In this video, I'm going to go through what coding is and what blueprints are. In order to understand how games are made, we must first analyze the role programming has in all of this. Programming, in a nutshell, is a way to communicate with the computer and tell it what to do. The same way you use a language to communicate with people. For example, if your brother didn't know what a salad is and you want to tell him how to make it, you would need to break it down into small steps. Get some vegetables, cut them into small pieces, mix them together. The same thing applies to computers. Computers don't know what a salad is. So if we wanted to make a salad in a video game, we can't just tell it to make a salad. Instead, we would need to give it specific instructions. Computers understand programming languages. Not even that. The programming languages we use to make code are actually translated to binary. Zeros and ones. When we create video games, we need to give it instructions like, if a bullet hits your character, take health away. If health reaches 0, die. Or to give you a better picture, let's look at a game like Flappy Bird. At the bare minimum, you would need a play button that starts the game, the jumping and the falling when the player touches the screen. The pipes need to have collision to make sure the player dies if he hits them, and a way to count the score. All of these decisions and conditions put together establishes the system needed for your game to work. Now let's talk about how coding works. The same way we have grammar in our sentences so that it makes sense, we use math as grammar when coding. In our health example, we used subtraction. You can use everything from algebra, vector math, multiplication, division, addition, and much more. Then there are programming-specific things to learn. Imagine you had a robot, and you told it guard the door and only let in your family members. Then somebody knocks on the door. The robot checks if the person is a family member or not. If it is, the robot opens the door. If it's not a family member, the door remains shut. This particular instance is known as an if statement. This is how we make decisions when coding. You can also do something called printing, which is displaying information in what's known as the console. When using blueprints, however, code will print in-game. But keep in mind that this is for the developers to see and not the user. This is a very common thing to do in programming, but it's mainly used for testing purposes. The next thing you need to know before coding in Unreal Engine is variables. Variables are stored values like numbers, names, or something called booleans. Booleans are values that can either be true or false. These are used for the if statements I mentioned earlier. All of the variables are known as data types because they store different types of information, or data. Numbers are known as integers, floats are numbers but with decimals. Words, letters, or names are known as strings, and so on. This is the way it is in default programming languages, but in Unreal Engine things are a little bit different. For example, we have a bunch more variable types that don't exist by default in normal programming languages, like transform, rotator, or any of these other types that look like variables NASA would use. These differences, or additions should I say, is what makes game engines so great because they have added a bunch of stuff for us that we can use. Now that you know what an if statement is and what variables are, let me show you the difference between normal coding and using blueprints. I'm going to create an if statement using C++ code and then do the same thing in Unreal Engine to show you why blueprints are so great. The if represents the code so that the software knows we are creating an if statement. The numbers and the equal sign in the parentheses is the condition. So if 2 equals 2, we will get the true outcome. The true outcome is written in the bracket next to it. Here we have set the code to print out true if the condition criteria is met. The else is the alternative. So if our condition is not met, aka it's false, then we get the outcome of the code written in the bracket next to that. In this case, it will print out false. Now let's do the same thing in Unreal using blueprints. So in Unreal Engine, instead of writing the whole if statement, we can just search for branch. This is essentially the exact same code as I just showed you. In Unreal Engine, we have something called event begin play. This is essentially code that should be called when this actor that I am coding in spawns in the world. In this case, the third-person character, since Unreal won't execute code that hasn't been called. Then we can add a print code and set the true to print out true and the false to print out false. This is the same as writing the print line I showed you earlier. Then we need to set the condition. I will create a Boolean variable and by ticking or unticking it, we can set whether it's true or false. If we drag the variable out on the red icon next to the condition text, you will see that the variable is now connected to the branch. This is essentially like setting the condition in the parentheses. If we start our game, you will see that we get true. See how much easier it was using blueprints? If we imagine coding like writing a text, default programming would be like writing every word. Every word becomes a sentence, and every sentence makes up the text. When we use blueprints, it's like we're using pre-made sentences. The sentences are already made up in the engine. We just connect them together to make our own text. Pretty cool, right? Blueprints are essentially pre-made code. So now you know the absolute basics of coding. Let's get more Unreal specific. I am currently writing blueprints in my third-person character class, but what exactly is a class? Find your content browser and hover the mouse cursor over it. If we right-click and select Create a new blueprint class, you will see all of these pre-made classes available for us. A class is a pre-made set of variables, settings, code, and other stuff. For example, if you want to create a car, you need to make the car able to accelerate forward, brake, swing properly, go into reverse, etc. Now you want to create another car. Instead of manually creating these settings all over again, you use a car class, which comes with these settings by default. So the character class is a pre-made human character class, which is very useful when making characters. You can also create your own classes, so if you wanted to create a four-legged animal class, you could. A class in Unreal Engine comes with a bunch of settings. Let's open up our third-person character class. There are 3 different tabs by default: the event graph, the construction script, and the viewport. The viewport is similar to the engine viewport, where you can see what your class contains, and you can tweak the default settings. Up here you can browse between different classes that you have opened. To the right, we have the settings panel. Again, similar to the engine layout. We can tweak things like the location, scale, rotation. You can press this arrow to reset the settings to the default. In the Animation tab, we can choose what kind of animation we want our character to use. This episode is not about how animations work, but simply explained. We can choose between 3 different animation settings. The first way, and the most common, is using an animation blueprint. This is essentially a system for the character's animations to blend together. So if the character walks, play walk animation. If the character jumps, play jump animation, and so on. The second option is using a certain animation. If you only need one animation, this is the way to go. And lastly, we can use custom. I honestly have no idea how to use the custom mode. You'll more than likely never need to either. In the Mesh tab, we can select what skeletal mesh to use. Below that, we can set the materials of the skeletal mesh. Every mesh that is imported into Unreal will come with different material slots. This particular mesh has 2 slots. You can clearly see where the materials apply. How many slots there are and what part of the mesh they cover entirely depends on how the creator of the mesh set it up. This is done in other 3D modeling programs and not Unreal, so it's not our problem right now. But if you want to know if it matters whether we use a bunch of material slots or not, yes. If we use a bunch of slots, it's easier to customize our character, but it comes at a performance cost. I will have a video very specific to performance, so don't worry right now, but I think it's a good thing for you to know. There's a bunch more settings here to tweak, but most of these settings won't make any sense for you right now. The last thing worth mentioning here is the character collision, the character shadow, or rather the mesh shadow, and the mesh visibility. You have probably noticed that we can do a lot of the same stuff, but from different places. Up top, we have some class-related settings. This is the class that we are currently debugging. Debugging is finding and fixing bugs or other related issues. Then there's the same panel as in the default viewport. The simulation button is for simulating code. We can use this simulate button to see what code is being executed. I like to imagine it as electricity flowing through the lines of code. Then there's a class defaults button and a class settings button. The class defaults is essentially the default settings for the class. If we press the class settings button, we get some other settings. You can see that it shows us our parent class, which is the character class. We can change this if we want to. So when we create a Blueprints class in Unreal, we need to select a parent class. That means that the class that we are currently creating is a child of the parent. So it inherits the parent's attributes. This is known as a parent-child relationship. Hide Unrelated is hiding unused code. The Find button is a search bar to find specific things. You can do this in your browser as well by pressing Ctrl+F. When pressing the Compile button, we can choose to save every time we compile and to jump to errors. I recommend not saving on compile since you might compile and test your game and it could crash. I also recommend to enable the Jump to Error button, since it will be easier to find your errors. Then there's a Save button. We have the perspective and lit view here as well. To the left, we have a list of things that are present. The first one, which is present in every class, is the self. This is the same as the class defaults button, and is pretty much an overview of most of the other settings. The capsule component is the character's collision. This is what prevents us from falling through the ground and walking through walls. We also have an arrow here. This is to indicate which direction your character should face. It's not necessary to use this, but it can be useful, no pun intended. Below we have our character's mesh. Keep in mind that the character class comes with a skeletal mesh and not a static mesh. That's because you can only rig and animate a skeletal mesh in Unreal. You can create a character using a static mesh, but you won't be able to animate it the traditional way. Then we have the camera, and something called the camera boom. Imagine the camera boom to be like a camera crane. We can change the camera settings like its location and rotation from both, but it's better for me to show you why we tweak the camera boom when we want to change the camera settings and not the camera directly. Then finally, we have something called a character movement component. This is a specific component made to handle movement-specific functionality, like walking, running, jumping, etc. Here we can adjust our character's movement speed, gravity, jump height, and much more. The movement component comes with its own set of variables and settings. For example, we have a variable called gravity scale, which refers to our character's gravity. Every class in Unreal will come with different default settings, but we can add our own with the Add button. Below we have something called events. This is related to our blueprint code. These events are responsible for different things, but since code cannot be called from nowhere, they need an event to be called. So the begin play event, for instance, is called when the actor begins to play, aka spawns in the game, and the rest of these events are called during input. In this case, the camera movement when we use the mouse, and the WASD keys to move, and the space button to jump. The event graph is where blueprint code is done. We are currently in our third-person character class, so the code we make here is responsible for this class. We call code by right-clicking and searching for what we want. You already know about print and branch, but there's a whole sea of more available code. Then there's the construction script. It is easier for me to show you what this does. The construction script is a special part of Unreal Engine Blueprints that lets you set up and change how things look or behave while you're still in the editor before the game even starts. It's like telling Unreal how you want an object or actor to be built or customized, and it shows the changes immediately in the editor. So for example, this is code to change the character mesh material, but this code won't execute before I start the game. Now let's see what happens when we do the same thing in the construction script. Pretty cool, right? We can also see the list of variables this current class has, but keep in mind that the character movement component variables, like gravity, for example, don't show up in the variables list. In the next episode, we will start to make some blueprint code.